If you're just giving it out, I'll take it.
All right, what kinds of things might limit a population from growing? What do we have? Okay, natural disasters, what else? Disease, what else?
Let me go on the back.
Lucky day.
Is it number 1? Oh my god. Brush 1 is number 1.
All right, disease, what else? Pollution, okay. Predators, food, space. So lots of things. That's what we're going to be talking about today, okay, is all of the different things that limit populations. So chapter 6, we are going to be looking at population and community ecology. So this should be a review from bio-ish. We might go a little bit deeper. We'll be talking about competition, predation, parasitism. We'll talk about carrying capacity, limiting factors. And then chapter 7 is human population. So we'll be talking about exponential growth, logistic growth, and that's pretty much it. Okay? So that's where we're going. You can expect a test probably before like winter break. I will try to put it on a day. I can be flexible. I will try to put it on a day where you don't have a ton. I hate doing it like the Friday before because everyone does it. So we can talk when it gets closer, but in like 3-ish weeks, 2.5 weeks. What? That's what I was thinking is on Wednesday, but what? So we have, if you look, we have.
When do we go on break? That's my question.
We have next week is the 10th. Okay. The following week is the 17th, and at the end of that week, on the 21st.
That's when we go on break.
And that's when we go on break.
Okay. So do it.
So I was thinking of like Wednesday the 19th. We'll talk when it gets closer. Yeah. I have no idea how many candles are on a menorah. I'm sorry.
What the hell's a menorah?
All right. So here's what we're going to do. We are going to grade the free response questions. Okay? Remember, you are grading the other classes. Okay? A lot of them have fake names. Some of them forgot to write fake names. That's fine. Here's what's going to happen. Okay? You need to highlight where they got the point, okay? So you're going to get their sheet. You're just going to highlight where they got the point. If you want to write like 1 point, 1 point, 1 point, you want to write on it, go for it. But you need to highlight where they got the point. I have highlighters up front. The total is 11, okay? But I'm grading them out of 10, okay? The maximum number is 10. So even if they get 11, you can write 11, but I'll put 10 in the grade book. Sometimes they do this. They have an extra point in there. Even though there's 11 total points possible, they only grade it out of 10, okay? So here's the scoring rubric.
What is this? This makes no sense. 604?
That's what class period you're in right now.
Okay.
It says during CNC. So when you're done, you can come put them up front. All right, so population ecology is what we are talking about. Or you should have heard some of this from biology, and if you didn't, don't worry, it's not super complicated. So.
Can I still sign up? Dude, I don't know how to understand. Can I just come?
So I will not be here. I will not be here on Friday. Or I mean on Thursday, sorry. Is this supposed
getting me crayon.
You asked me. Ask me in your group because I can't.
All right, write down.
Don't mind me. Come on. I'm not going to say something.
So I tried my hardest to stay here on Thursday, but they're making me go. They're making me go to meetings, so I will not be here on Thursday. But I made an activity for you, and you should be able to do it all on your own. No. So you should be able to do the activity without me, but you can always message me on Remind or email. I will have my computer and my phone like all day, and I will check it during this class. So if you have like a question, you can always message me, and I'll get back to you right then. Okay? All right. So population and community ecology. So this should be, we learned about this in biology. Population is a group of individuals of the same species living in the same space. So when we talk about the human population, it's typically just humans. When we talk about an elephant population, it's just elephants. So same individuals living in the same or the same individuals of the same species living in the same area. I won't be here. A community then is all of the living things in an area. Okay, so it's all of the populations together, all the zebras and the elephants and whatever else. And then we have an ecosystem. An ecosystem is all of the living and non-living things in an area. So we talk about non-living things like dirt and water and sunlight, temperature, wind. I record yours for AP. I don't record bio because bio goes at a much slower pace, and so no, I have a yeah. Because it's usually always a train wreck. Second time's always better when I record. No, I just usually like. All right, so the big idea here is that populations are dynamic, and what this means is that they are always changing. Okay, we talked about inputs and outputs. So inputs, things going in. So we might have organisms coming in. We might have resources coming in. And then outputs, things coming out of the population. Okay, we might have individuals moving out of the population. So when we talk about populations, we can talk about a lot of different things with regards to those populations. Okay, we can talk about the population size. If you get into classes in college that talk about ecology, you'll see that population is often abbreviated with the letter N, capital N. Okay, total number of individuals in an area. So anytime we talk about a population, typically in an equation, it's the letter N. Just like how if you talk about slope in math, it's M. So we have different abbreviations. We can also talk about the density of the population. The density refers to how many individuals there are in an area. So if I only have one person in the classroom, it doesn't have a very high density. Well, what parts of the United States? Yeah, New York City, Los Angeles. What states have a low population density? Yeah, Wyoming, some of the out-west states, right? Utah. So same thing we can do for populations. Okay, we can look at where they have high densities and low densities. And a lot of times they'll use this for limits on hunting and fishing rather than just looking at the total population, because the total population doesn't tell you how much area that population actually covers. We can look at sex ratio, so males to females. If there are a lot of males and not very many females, we can predict that the population might not grow as rapidly as we want it to. Age structure. So we can look at how many old and young individuals there are in a population. This is important because it will tell us if our population. I'm handing back your reviews. I mostly just graded the front or checked the front page. Again, I always give you completion points on the review, so as long as you do the whole thing, you get all of the points. I check the multiple choice, and I'll check the math. But other than that, I don't typically check your answers because I need my sanity. So if we look at this pyramid here, you may have seen something like this before. I may have made you make one in bio. Maybe you didn't, which is totally fine. So what this is showing us is that individuals 0 to 1 years old, okay, make up 20% of the female population, 20+% of the male population. So we have the most individuals here that are 0 to 1. As we get up, the individuals decrease. So what we can see is that we have a large amount of individuals that are really young. And what we can see is that that will probably cause our population to grow. If it were the other way around, and we have a lot up here, we would expect our population to decline. Why? Because these people are going to die, and then there's not going to be very many people who can reproduce or at a reproductive age. Whereas here, okay, these old people die, but we have a lot that can reproduce and create more offspring. We're going to talk about distribution. So organisms can have different patterns that they're found in their populations. So organisms in a population can be distributed in one of 3 different ways. The most common one that we find is a clumped distribution, right? Clumped is this one down here where we see all the dots clustered. Reason that they might be clumped is because they live in packs, or they cluster where the resources are available. Imagine you're in the desert, and there's one little watering hole in the desert. You'd probably have a lot of the plant species and a lot of the animals hanging around that watering hole because they all need water, and it's the only resource around. They can also help protect each other from predators. So for example, zebras, they actually take turns looking out. So they have big packs of zebras, and some of them are on watch out, like watch duty, okay? So some of them will watch out for predators while the other ones are eating their grass, right? Because when they have their heads down, they can't see those predators as much. So they help protect each other. So again, this is the most common. You'll see lots of little dots. If you want to draw that in that box next to it. So the clumped one is this one here. So just cluster some dots right around that area. All right, the next distribution we have is uniform. Okay, if I have a uniform on, a uniform makes everyone look the same, right? A school uniform. So uniform distribution occurs where resources are scarce, where there's not a lot of them. They maximize the distance in between individuals. They make sure there's a lot of space. This helps avoid a ton of competition or territoriality, but basically they're spread out equal distance from each other for some specific reason. We have some plants that do this. So for example, the creosote bush. Okay. Again, you don't need to know like the name of the creosote bush, but it's a bush, and what it does is it releases chemicals through its roots, and those chemicals prevent other plants from growing next to it. So it actually can prevent plants from growing next to it, and we end up with that spread out distribution because all those plants are releasing those chemicals and preventing the other plants from growing. So uniform, you can just put some even dots. You see this a lot in plantations, like tree plantations or farms, right? They're evenly spaced out. You might see even rows. And then lastly is random, okay? So random is just kind of all over the place, and it's least common. It's found typically where there's just plenty of resources, so organisms just end up randomly distributed. All right, so random. So these are the different types of distributions that we see in nature. All right, here's the last thing we are writing down today. Population size is affected by density dependent and density independent factors. So density dependent. Okay. I'm going to shorten this. Hold on a second. I guess I'll leave it at that. You could even shorten it factors that depend on the size of the population if you don't want to put the other ones. So density dependent, they depend on the density. So if my population has a higher density, it's going to have more of an impact. Okay, so they depend on the size of the population. So if my population gets bigger, they're going to have a bigger impact. If my population is smaller, they're probably going to have less of an impact. So these would be things like food. Let's say I have 10 slices of pizza. Okay, if I have 10 kids, there's not going to be as much competition, right, for that food. If I have 10 slices of pizza and 10 kids, okay? If I have 10 slices of pizza and 100 kids, there's going to be a lot more competition. So my size, my density of my population impacts how much food there is available or how much competition there is. Disease. If I have one person on an airplane, chances of them getting sick are not very high. If I shove 200 people on an airplane, chances of them getting sick is a lot higher. Okay, why? Because there's a higher density in that airplane with 200 people because they're really close to each other. We also have density-independent factors. No matter what the size of the population, they will still affect it. It won't change the effect. They will still have an impact, okay? These are typically things like weather and climate, things that can't really be controlled very easily. They're not biological, meaning they're not living things. So that's where we're going to stop there. What I would like you to do is I would like you to see if you have a yellow sheet around your desk somewhere. If you don't, I'll come around. We're going to be reading about yellow perch and looking at the limiting factors. Last year, sorry, this is a repeat. For the rest of you, it should be good. So yellow perch in Lake Winnipeg. Okay, so Lake Winnipeg is located in Canada. And we are going to look at how the yellow perch are limited. So I'm going to read you this reading. And as you're reading through it, what I need you to do is think about all the things that are limiting the yellow perch population. There's lots of different things. And I'm going to have you write down the limiting factors of the population in a minute. So we're going to read through this. I'm just going to pull it up for the people that are reading recorded. So Lake Winnipeg is in Canada, and it is a lake that is home to lots of different fish. Here's our reading. All right. So located 711 feet above sea level, Lake Winnipeg is a shallow lake located in Manitoba, Canada. Okay, apparently I rewrote this since I gave it to you. So I'll read yours. Lake Winnipeg, it's composed of two basins, a wide north basin and narrow south basin. It is about 12 meters deep, and it receives 517 millimeters of precipitation annually. Okay, so it's a big lake, it's shallow, it's large. Lake Winnipeg provides a habitat for over 50 different species of fish, including yellow perch, chestnut lampreys, and rainbow smelt. Yellow perch prefer water that has little current. They can tolerate moderate turbidity. Turbidity is like the cloudiness of the water. Also, they prefer a temperature range of 18 to 20 degrees Celsius, which is like 65 to 70 degrees Fahrenheit. If the temperature of the water varies too much above this range, yellow perch will either move to a new location or die. Yellow perch spawn in May or June when water temperatures are above 6 degrees Celsius. First, they migrate to tributaries, and then several males attend a female while she releases her eggs. Yellow perch can grow to 302 millimeters, so roughly about like 12 inches in length. Their lifespan is approximately 9 years. If there's a lack of resources or too many of them, if there's overpopulation, yellow perch adapt by stunting. This means that instead of starving, they simply do not grow as large as usual. Thus, they're able to live off of less food. Yellow perch feed in midwater or on the bottom of Lake Winnipeg. They eat a variety of invertebrates, such as fish, and fish such as emerald shiners, the fish pictured at the right. The eyes of the yellow perch allow them to see almost 360 degrees around them. Thus, they are better able to spot their prey and evade predators. In Lake Winnipeg, yellow perch are eaten by northern pike and walleye. They're also caught for food by commercial fishers and anglers. Chestnut lampreys are also found in Lake Winnipeg. Lampreys, pictured at the left, are parasitic fish that attach to other species of fish, such as yellow perch, to feed on their blood and tissues. Recently, rainbow smelt have been introduced into Lake Winnipeg. Rainbow smelt are a very invasive and competitive species. They have been thought to have caused a decrease in the emerald shiner population. Lake Winnipeg provides a home for many species of fish. However, a severe drought could disrupt this ecosystem greatly. Lake Winnipeg's water level would drop, the temperature could change, and it could become more turbid. Thus, the carrying capacity of the lake would change. But in its current condition, Lake Winnipeg is an excellent habitat for many species of fish. So here's what we're going to do. We are going to look at this sheet that I'm going to give you now. Don't worry, we'll be able to finish it. We're going to work on it together. So the first thing I need you to do when you get this sheet, see if you can list as many things that limit the yellow perch population as you can. And that's number 1. List as many things as you can that limit the yellow perch population. What are some things we can think of off the top of our heads that limit them? Okay, good. The temperature could be something you write down. What else? Turbidity, so the cloudiness of the water. Yeah, I know, it's missing an R, sorry. Turbidity. We'll learn about turbidity when we talk about water quality and sampling. What else? Temperature, turbidity.
The currents.
Does it say currents? Yeah, currents. I'm sorry, I don't have this entire thing memorized.
I was just thinking about if I take the test tomorrow and I get 100 on it, you'd not believe it. You'd think I cheated it no matter what. You believe I cheated, this is like, I just think about it. So we might as well just get it wrong.
You know, you get 100, huh?
Yeah,
What else limits the perch population?
No, I don't. I can show you the photo.
Come on, people. Food, habitat. What? Overpopulation. Parasites. Yep, predators. Invasive species. Drought.
Nothing to do with anything.
All right, so let's look at the statements below. It says rainbow smelt and yellow perch attempt to occupy the same area. The more aggressive smelt survive, the perch do not. So what would be the limiting factor? What's limiting them in that scenario? Okay, so competition like for space. Competition for space. So you could write space or habitat. So space or habitat, would that be dependent or independent? If I have more fish, is that going to impact the amount of space I have? So it's going to be dependent because the more fish I have, the less space. Number 3, a severe flood brings a lot of sediment and silt, dirt, into Lake Winnipeg. The turbidity of the lake increases greatly. What's the limiting factor? Turbidity. Somebody whispered it. Okay, so turbidity, is that dependent or independent? If I have more fish, is it going to impact more or less fish? Is it going to change the turbidity of the water? Probably not. So that would be independent. Anytime we're talking about like weather or climate, it's going to be independent. A drought decreases the water level. The carrying capacity then decreases. Carrying capacity just means how many fish it can hold in the lake. So what's the limiting factor? What's limiting it? The droughts. The droughts. And you guys can just abbreviate these if you want. A lot of my bio kids abbreviate them DD or DI. That's fine too. So is this dependent or independent? A drought. Independent, because if my population's bigger, it doesn't mean the drought's not going to happen or it's going to be less severe. The drought's going to happen no matter what. It doesn't depend on the size of my population. Due to the introduction of rainbow smelt, Lake Winnipeg becomes crowded. Some fish do not survive. Limiting factor? Space, yep, or habitat, either one. Dependent or independent? Dependent, right? Because the more organisms I have, the more or the less space I'm going to have. All right, 6, since northern pike prey on yellow perch, an increase in the perch population causes an increase in the pike population. So what would limit it? The predators, okay? So predators. So predators, would that be dependent or independent? If I have a higher population of perch, is that going to influence the number of predators I have? Yeah, because there's more food for them, right? If I have a lot of little rabbits, that could make my population of wolves go up because I have more rabbits to feed them. All right, many fish die due to an increase in water temperature. So limiting factor would be the temperature, number 7. Would temperature be dependent or independent? Independent, because no matter how big my population gets, the temperature is still going to change. All right, number 8, overfishing. The number of walleye in Lake Winnipeg decreases. What's the limiting factor? Fishing. Okay, anything that's a human impact is always going to be independent because humans are going to do what they're going to do regardless of how many species there are, for the most part, okay? So we're going to say all human activities are typically independent. All right, parasites cause the disease to spread quickly, so the limiting factor for 9 would be disease. Is that dependent or independent? Disease? Dependent, because the more individuals I have that are closer together, the faster that disease is going to spread. And last but not least, they migrate long distances to spawn, and many do not survive. So the limiting factor would be like the distance, and that would be independent. You can keep this. I will see you all tomorrow. Yellow sheet can stay on the desk.